Professor Srinivasan obtained his undergraduate degree in physics from the University of Madras, followed by ME in electrical engineering from Indian Institute of Science, specializing in biosignal processing. He joined the doctoral program in cognitive psychology at the University of Georgia in 1992. In his doctoral work with Dr. James Brown, he investigated the interaction between attention and spatial frequency processing mechanism. He did postdoctoral work at the University of Louisville with Dr. Edward A. Isaac on diagnostic algorithm for glaucoma before joining CBSCS. He worked at the Biomedical Engineering Research Center at Nanyang Technological University, Singapore. At CBCS, he uses multiple approach to study mental processes. He is interested in studying perception, attention, consciousness, emotions, self and decision-making processes. A team from DEI visited CBCS Allahabad in May 2012. Professor N. Srinivasan visited DEI Center of Consciousness Studies also in June 2012 and had a roundtable discussion. I invite Professor Srinivasan.
Thank you. I would like to thank the organizers for inviting me to give this presentation. All the hard work that I'm going to present was done by my student Dev, so all the credit goes to him. Okay, so before we talk about it, first I will briefly talk about the kind of perspective that I'm going to bring to talk about self and consciousness, essentially focusing on the link between perception and action. Then I will briefly talk about what the event control approach is, or exactly what we mean by that. And then I will talk about two studies that we have conducted and present the results. Okay, so let's start with something fairly simple. You have an organism interacting with the environment and presumably perceives whatever information is available in the environment and performs certain actions on the environment. And then this keeps going on and on, okay? Not only that, when, at least in our case and most of the social animals, there are other environmental agents present in the environment and again are making lots of changes to the environment. Not only we are changing the environment, but other organisms too. And of course, we perceive other environmental agents as well, okay, and what they do. So this keeps happening. Now, a lot of times when people talk about perception, cognition, and action, Susan Hurley called it the sandwich model. You have perception, then you have cognition, then you perform an action, some kind of a feed-forward chain, if you want to think about it. In that perspective, perceptions and actions are actually separate from each other. They are at the end, and you have whatever cognitive processes that you want to think about are somewhere in the middle. Okay, now the question is that are perception and action really peripheral? They are in two corners and separate from one another. Okay, now there is of course lots of supporting evidence from the context of visual perception that I study. For example, Milner and Goodale have argued that there are two visual systems that are kind of partially independent from each other. So the ventral system is presumably for perception according to this view, and the dorsal system is presumably for actions. However, people going back to early work on perception, a lot of people have argued that perception and action are fairly tightly coupled. For example, James Gibson strongly argued that perception and action are tightly coupled, and many other viewpoints exist. For example, cognition apparently emerges out of the dynamic interaction between action and perception. Bernard Hamel has proposed an event coding model in which perception and action share common resources. And Susan Hurley has talked about some kind of a two-level interdependence view. The question that one can ask is that how is the perceived event that we perceive a particular event influenced by how loose or tight the coupling between perception and action is? You can call this also binding. We will make. And you can ask other questions. For example, does an intention to perform an action actually influence what we see? So there is some evidence that it actually does. A student of mine will present some work on time perception, I think day after tomorrow, but we have other evidence as well. Now, there are a lot of ways to talk about it. I'm just going to present some work by Dennis Profit, where people have argued that perception is actually closely linked to action planning. In fact, Jordan in his paper actually uses the phrase, to see is to simultaneously plan. This brings in the notion of embodied perception. So for example, in this particular study done at University of Virginia, people were asked to measure the slant of the slope here using both visual or verbal measures as well as the haptic measure. And the finding generally is that people overestimate the visual measure, whereas the haptic measure is fairly accurate. Okay? Now, interestingly enough, people also overestimate if you just put them a backpack on them and ask them to estimate. They don't have to walk, by the way. They just have the backpack, and still they end up overestimating the visual measure, but the haptic measure is not affected at all. So it's almost like visually as they are seeing, they're planning in terms of if I have to walk, and essentially that influences the way they perceive the slant in this particular case. People have looked at other factors, and one thing we will start looking at here is control. And I'm going to show, most of you may have seen it, but let me just show the flash lag illusion anyway. In the flash lag illusion, there will be a white dot, for those of you who have not seen it, at least in this version, that will move around in a circle. As it moves around in a circle, there will be a red square that will come. Your task is to tell that when the red square was flashed, where the white disk was. Okay? So let me just play it. So it will start here. So where was the white disk when the red square flashed? Somebody help me. Okay, let me play it again. That works? Yeah. Anybody? Somewhere here? Okay. Well, okay, so most people say it's here. There is, of course, variability. When the red square came, the white disk was actually here. But in general, people perceive the white disk to be here. Even though they were presented simultaneously, there is a flash lag effect that the flash is perceived to be ahead of the moving flash, ahead of the red square. Now, one interesting thing about it, there are many interesting things about it, but one of the interesting things is if you are allowed to control the white dot, the illusion magnitude changes. So rather than passively perceiving this, if you actually are able to control this white disk, then your illusion magnitude changes. Saying by interacting with the environment, your actions actually changes the way you perceive, in this case, timing of a particular event. Now, in a related manner, Dewey and colleagues, they actually used a virtual boat which participants actually controlled to go through some kind of troubled waters with some noisy environment, supposed to reach a goal point, and they were explicitly asked to judge how much control they had over the boat. The important point was that when the environment noise led participants closer to the goal, where they have to get, they actually reported greater control. Okay? So essentially, these kinds of findings bring us to the event control theory. One of the points is that we want to combine perception and action into just calling them events, or perception action events, or generally just events. The second point that we want to make is that events have hierarchical structure. So you have to think of a hierarchical control system, and I will just show you an example of it. So when you have a system, you have control operating at multiple levels, and then these levels change in terms of spatiotemporal distance. So for example, this is from Jordan. you can think of, for example, as three subsystems. Each of them have control operating at different levels. What distinguishes these things is that they are nested within each other, and one parameter that distinguishes them is the spatio-temporal proximity. So these effects are occurring at short time intervals or space as well. Whereas as you go in the hierarchy, up in the hierarchy, the way this is presented here, this spatio-temporal distance actually increases. Okay? Now, so the issue is that the degree of binding, if you have a perception and action and if you combine them, then it can be quantified by the amount of control exercised at that particular level. So if you have different levels, at each level there is a perception action events occurring, and the binding between them would, of course, be determined by the amount of control. So the control for each level of coupling based on differences in spatio-temporal distance obviously would also depend on control at other levels. So we will see one example of it. So this relationship is hierarchical, and the control you exercise at a particular level, say the higher level, would depend on control you achieve at the lower level. Now, if you're going to use control, or the kind of control a particular system can exercise, there are two kinds of things that is going to affect how it works. One, you're going to make prior predictions or intentions of the system. The system is going to make a prediction. Andy Clark has written a BBS paper arguing that brain is a prediction machine. You're going to make predictions which influences the action that you're going to perform to achieve a particular effect. Of course, post-event analysis of whatever the consequence of your action, you're going to perceive them as well, and this is going to keep happening over an extended period of time until typically you achieve a particular goal given the task. So in the hierarchy, the way it works, post-event perceptual information kind of travels bottom up, and prior predictions travel from top to bottom. Okay? And each level, the couplings, the lower level couplings are constrained by information provided at the higher level. This is not a really good picture of it. I have no idea how to represent it. But essentially, you have different controls, loops. You can think of, for example, a reflex is something that happens at a very low level, something that is spatio-temporally very proximal and happens immediately, whereas maybe long-term planning that you do probably would come somewhere here. The bottom of control information travel upwards. The top-down control provides constraints to the lower loops. And coming to the self would be characterized by the highest level in which control is actually achieved. So at a particular period of time, whatever level in which the control is achieved, that is, in some sense, the way you feel about yourself. Okay? Just to give a kind of intuitive example, here is a beginning pianist. Now, you may have stronger sense of self in terms of, if you ask him, you would describe in terms of the finger movements that he is doing. Or, for example, a beginning driver would think in terms of various actions proximally that they are performing, whereas an expert pianist would think in terms of the melody being played and identify with the melody being played, even though he may be performing the same movements or precisely. Okay, so the way in which you perform expertise essentially means that you are operating at a different level in this particular system. Now, the focus of the talk, of course, is not on all aspects of self. It's just on one particular aspect, which is sense of agency that many people have studied. And it's an important thing that as we perform actions, we have a feeling that we are the owners of the actions that we did something. And we want to analyze different aspects of sense of agency as a function of, one, the notion of hierarchical control, and in terms of how control would change or influence sense of agency. Okay? Let me just skip it. Now, to do this, of course, and to really talk about this issue, we need to have other agents, because as we perform actions in the environment, other agents are performing different, maybe similar actions in the environment. Maybe you are working as a team. So agents may share common perceptual actions events as well. They may share the same goals, may perform different events. So one thing is that we wanted to study it in the presence of other agents. So to do it, essentially, we came up with a particular experiment. You can think of it as a game. We hypothesized that people's sense of agency would depend on control, and not only in terms of if there are two levels of control, exactly what they achieve. This experiment was designed using MATLAB and the Psychophysics Toolbox. I will just show you the picture and probably make more sense rather than describing it. Essentially what you have is a bunch of color circles. A participant has to play a game, or in a particular trial, there is a blue, you can call it sheep, X that is around. Then there are a bunch of wolves. Some are moving randomly. Of course, some are actually trying to catch the sheep. Okay? Your job as a participant, you have two tasks. One is you have to catch the sheep, number one. Number two, of course, you have to identify yourself. Let me explain to you what it means. What you have is a joystick in your hand, and you are trying to control the movement of one particular circle, and you have to report which circle that you were controlling, okay, through your joystick. So for example, this is moving, and well, this is just a demo. Well, 5 could be anything. If 5 actually catches, and if 5 is the one that you are controlling, you're supposed to report the label 5, okay? You may be accurate, you may be inaccurate. What will actually happen is that all of them, in the previous case, they were all colored differently for your benefit. Okay. Now, actually speaking, all of them are colored the same way with just a single label. So you do not know which wolf you are controlling. So the task is two things. One, you are supposed to catch the sheep, but you do not know which circle or wolf you are controlling. Okay. So simultaneously, you have to figure out which circle you are controlling and also catch the sheep. Is that clear? So the point here is that if you have to identify what kinds of processes are involved in terms of control, and the particular goal is there, of course, to catch the sheep in this particular case, but you have to figure out, in some sense, which one you are controlling, essentially by observing what is happening on the screen as a consequence of the actions that you perform. Okay. After a particular trial, there were few questions. The first question was, which wolf were you controlling? Then how much you identify with the wolf that you have chosen? How much do you think your actions affect the movement of the wolf? And of course, there was another question which didn't really work. They were on a 9-point rating scale. We predicted that the amount of control would actually influence their identification performance and also would have an effect on the ratings. And we also predicted that in high control conditions, there would be a greater sense of self as agency. Okay? In fact, people actually, as they play it like a video game, they would start thinking that the circle is actually there, but that's not part of the data. Okay, let me present the results here. What you see in this panel is control was manipulated in terms of amount of control they had over the joystick. Essentially, that is governed by one, what they actually do, plus the other part is governed by the computer, essentially. So in the 0% control condition, essentially the computer determines how all the circles move, even the circle in which you are supposed to be linked. And of course, in the full control condition, the circle moves exactly, with some noise, of course, is there, but exactly how you move. So two things to note here. The data is split into two in terms of one, the circle that you controlled actually managed to catch the sheep. So you achieved the goal that you wanted to achieve. So that are essentially the black bars. And the white bar indicates essentially when they did not catch the sheep, but still correctly identified which circle they control. Okay? So the question is, how does this identification performance change as a function of control? So if you look at it, when they caught the sheep, of course, if there is no control, things are very poor. but the amount of control actually did not matter. There was no effect at all, whether it was 1/4 or full. Whereas when they did not catch the sheep, the actual amount of joystick control did influence their identification performance. So when they achieved their goal, the top level goal of catching the sheep, the actual amount of control did not matter. As long as they had some control, that's fine. It's pretty much did not vary as a function of the joystick control. But when they did not achieve the goal, they moved to one level lower. Now the exact amount of joystick control actually influenced identification performance. If you look at the ratings, you have similar effects. The black bars, they are not significantly different. There is some more noise here, but the white bars are different. So there is a main effect of control when they don't catch the sheep, but there is only an effect in terms of none versus something, okay? Whereas the actual amount of control did not matter. So I think to summarize the results, when the trials in which they were not able to catch the sheep, both the percentage of correct identification and experience of agency in terms of their rating increased as the amount of control was increased. When they caught the sheep, even a small amount of control was sufficient, and the actual amount of control did not matter. And they had a greater sense of agency when they achieved the goal. So it suggests that there are two levels, at least in this particular experiment. One, they have a top level in which they're trying to catch, in this particular case, a sheep. Then you have another level in which you have perception action through the joystick control that they have, that experience they have. So when they don't achieve the goal, their ratings now depend on exactly the experience they had as they interacted with the joystick and the monitor in terms of how they moved, actually. Okay, so the study suggests that the agency depends on the amount of control and also increases with the amount of control. Now, one of the problems is that whether they caught the sheep or did not catch the sheep, we did not do anything. So it was up to them. So obviously, when the control levels were lower, they struggled to catch the sheep. When the control levels were high, because this was done post-hoc analysis in terms of whether they caught it or did not catch it. We did not manipulate it, okay? So to make it more balanced, we did another experiment where we had only one competitor wolf, which they did not know who that was, which was the purely controlled by the computer, and essentially had the same goal. So now there are only two, you and the computer. And essentially there were a greater chance of misidentification and a roughly equal chance of winning or not winning, okay? Although it's still not explicitly manipulated, we tried to get the balance right. And we wanted to see the pattern of misidentification, actually. What happens, in what cases they actually make a mistake and say that the actual circle that was controlled by the computer was actually controlled by them. So what we did was we manipulated, one, the congruency between the joystick movement and the movement of the user agent. We also changed the strength of the competitor wolf so that roughly we get this balance. The parts that are similar to the first experiment I'm not going to present. Here, all I have done is presented when they have actually made a mistake, when they have misidentified the circle controlled by the computer as controlled by them. Okay, so it's just actually pattern of errors in this case. So, excuse me. So they have misidentified as chaser. There is one chaser wolf, and there are a couple of non-chaser wolves just randomly floating around. So when they misidentified as chaser, that happened mostly when the computer actually achieved the goal. Actually, the circle that achieved the goal is actually controlled by the computer. When that happened, that is when they are actually saying that that is the one that I was controlling. Okay? Does it make sense? So their goal is actually achieved by another agent, but now they are claiming that it is actually they, or the circle was controlled by them. Okay? You get similar things in terms of ratings as well as in terms of control. Okay, going back to the next portion of the talk, Patrick Agard and colleagues have looked at the effects of intention or intentional actions on, in this particular case, time perception. So here is the basic paradigm. You have a clock, which is popularized by Benjamin Libet type study, where you have a clock, an arm is moving, and then you followed by a voluntary key press, and then there is a follow-up event that occurs. In this case, it was a tone, and then people were asked to estimate, essentially, the time between this. Okay, actually, they just need to indicate the time in the clock, and then the difference between the two is calculated. So what Haggard showed was that when subjects performed an intentional action, then the time between the action and the resultant effect perception was shorter when it was perceived as a voluntary or an intentional action compared to when it was an involuntary movement or even stimulated. He also did a TMS study. Okay? So when it was an intentional event, that action that you performed and produced the effect that you desired, you perceived them to be closer in time. And he called it intentional binding. Okay? Because this is binding in terms of time between an action and a consequent perception. Now, people have looked at, looked at control and intentional binding, and they have used to measure intentional binding as some kind of an implicit measure of sense of agency. Of course, you can also ask an explicit question and a rating, and that would be an explicit measure of sense of agency or sense of authorship. Different people use slightly different terms. So what we wanted to do is to look at essentially using the similar kind of paradigm, but look at whether an implicit measure of sense of agency, which is essentially intentional binding in our case, a time perception estimate, an explicit rating, how would they depend on control that we could manipulate? So we did a second study where we manipulated control and to look at two measures of agency. I will just quickly go. Essentially, what they have to do is to report interval duration between an action they perform and a perceptual event that will occur. They have to estimate the time. That's one task. Second task is just like before, they have to achieve a particular goal. I'll quickly show you. The question they asked was how much it felt that you control the event. This was a similar question used by Wegner and colleagues. This is, of course, the training part of the study. Essentially, people are asked to press a trigger, a blue circular disc comes, and then at different SOAs between when you press the key and when this circle appears on the screen. People responded, then they were given feedback so that they were trained to do it reasonably accurately because they have to give a numerical estimate. Okay? So this is first phase of the study. The second phase of the study essentially involves some kind of a shooting a target task. So essentially you have a red crosshair on a scene and people have control over the joystick. They have to move the joystick and then align and then fire. Okay? Press a button there. That is the task that they have to do. As soon as they press the button, a blue disc will come and people have to estimate the time between when they press the button and when the blue disc came, and so there will be an estimate as well. Let me show you, just to get a feel for it, how the video looks. Although this is a very case in which the noise is fairly low, you can see the crosshair moving. Well, in this case, this is just a video setup. Once it moves, maybe you will stick. Immediately, a blue disc will come at 3 different SOAs. So you will see again. Once you shoot, then a blue disc will come. Okay? And then people have to estimate the time. There were 3 SOAs that we used, 100, 400, and 700. Okay, so let's look at the results. So we had 3 levels of control. The control here is joystick, but the noise essentially added by the computer is what is manipulated at 3 different levels. 0.2 means you have very little control over the joystick. One means you have perfect control over the joystick. So you have 3 levels of control. You have 3 SOAs, 100. The reason is that intentional binding has shown to be stronger at shorter, in these kinds of studies, at shorter SOAs. So we use 3 SOAs, 100, 400, and 700. The question is, how does it change as a function of control? And also whether they achieve the goal, in terms of whether when they short it, they actually hit the target. Well, in the example that I showed, the target was hit, but it could fall on the side, especially under low control conditions. It's very difficult slightly more difficult to hit the target. Okay, when the goal was completed, that is when they actually managed to hit the target correctly, then the actual amount of control did not matter at all. Their time perception estimates did not vary as a function of control. Okay? It's pretty much no effect. When they did not achieve the goal, that is when the actual amount of control mattered. So you can see that the estimates are shorter when they had higher levels of control over the joystick. Okay? You can see that generally it's falling. Now, when you come to the explicit measure, we had a rating question. Now, it really did not matter in this particular case. In all the 3 cases, essentially, generally ratings went up, even when the goal was completed, or even when the goal was not completed. So the implicit measure in this particular case, yeah, it's done, did not change as a function of control when the goal was completed, but change as a function when the goal was not completed. But here it did not matter. There was a main effect of control for both cases. Okay? So let me finish it. So when, as I said, that now we have a difference between whether the goal was achieved or not, but that influenced 2 different measures of sense of agency. One, an implicit measure of time estimation between the action and the consequent perception. In other case, the rating, the effect changed. It was dependent on, whether the goal was achieved or whether, control was there or not. Okay, let me finish. We argue for talking about self, naturalizing self using the event control approach. Remember, we are not focusing on a particular moment in time at all. All these events that we are talking about are extended in time. Please keep that in mind. We provide empirical evidence for the approach by using a novel paradigm consisting of multiple agents, and they share the same goal, catching the sheep, to understand the emergence of self over time. The notion of hierarchical control is critical because whether they achieve the goal or not determines how they feel or how they identify or how they rate. Okay? And implicit and explicit aspects of sense of agency are mediated by maybe different levels of hierarchical control, and we hope these studies will prove useful in naturalizing self and provide evidence for the event control approach. Thank you.